Good day. We now have our lesson, the second part, which is line and planes in space, particularly lines in space. Last time we have dealt with the parametric equation of lines. So this time we have here now vector equation of lines. So by definition, a vector equation for the line L through the given point P sub 0, whose coordinates are x sub 0, y sub 0, z sub 0, parallel to V is R of t equals RO or R sub 0 plus TV, where the domain of t is from negative infinity to positive infinity or all real numbers, where R is the position vector of a point P whose coordinates are given as x, y, z on line L, and RO is the position vector of the initial point P sub 0 whose coordinates are x sub 0, y sub 0, z sub 0. So if we're going to geometrically interpret the definition, so we have here x, y is the axis. Then we have a line L. So this is your line L whose coordinates are given P sub O and P sub P, or rather P, whose coordinates are given. So for P sub O, we have x sub 0, y sub 0, z sub 0, and point P, we have the coordinates as x, y, z. Then you have now your vector V, whose initial point is at the origin, can be drawn in this manner. So it's parallel to your line L. So this is your vector V. And in finding the equation of your line L, in vector equation, so we have now R of t is equal to RO plus TV. So with that, RO is, we have it as the vector from the initial point to, which is the origin, to P sub O. So this is your vector RO. And with that, when we now define the equation, specifically the vector equation of your line L, R of t is RO, where we have it as x sub 0. This is also a vector, a position vector, and it is obtained by getting the difference of these 2 points, E sub 0 and the origin. We know that the coordinates of the origin is at 0, 0, 0. Therefore, it is x sub 0 minus 0, which is x sub 0. That is your RO. Then you have the second coordinates of your RO, second components, you have YO minus 0. Then we have ZO minus 0 is Z sub 0. So therefore, this is the vector whose components are the coordinates of a point on the line, as it is given in this definition of R sub O vector. Then plus T, and then we have your vector V. It is a non-zero vector parallel to your line L, whose coordinates we have it as ABC. So we have it as ABC in bracket form. So this is our vector V, whose components we have it as ABC. So therefore, this is now the vector equation of your line L. It is equal to RO plus TV, or we can also express it as R of t equals, we have x sub 0, y sub 0, z sub 0 plus t times, we have the vector V as ABC. By the way, it also says here that R is the position vector of a point P on line L. So we can obtain that as from the origin connecting to point P, that will be R. So let us have this example. It says here, find the vector equation of the line in tree space that pass through the points P1 and P2 whose coordinates rather are given. For P1, we have 3, 5, negative 2, and for P2, we have here 2, negative 3, 4. So if we're going to geometrically interpret the problem, so we have here now your line L passing through the 2 points P1 and P2. So we have here your line L passing through points P1 and P2. And the vector equation of the line L, we have the given formula R of t equals RO plus TV. So let's define RO. So RO is the vector formed from the origin connecting it with P1. So this is your vector RO. So RO will have the coordinates or components as the difference of the terminal point P1 and the initial point at the origin. So we have this origin as 0, 0, 0 as its coordinates. For P1, we have 3, 5, negative 2. So in getting now the components of your vector RO, it will be the difference between these 2 points, wherein we have the terminal point is P1 and the initial point is at the origin. So we have now RO will have 3, 5, negative 2. And then in getting vector V, which is now parallel to your line L, and it can be found by from your vector P1, P2, and the components of your vector V from P1, P2 will have it as 2 minus 3. So it's also terminal minus the initial point, which is negative 1. Negative 3 minus 5 is negative 8. Then 4 minus minus 2 is positive 6. So therefore, the vector equation can now be written as R of t is equal to R sub 0, where we have it as 3, 5, negative 2. Then plus we have t times your v, we have it as negative 1, negative 8, 6. So this is how we find the vector equation of the line L in tree space that passes through the points P1 and P2.